This unit is all about chemical reactions, which is one of my favorite units because there's a lot of fun labs we can do with this. But before we learn how to write a chemical reaction, we have to understand what a chemical reaction is. So let's talk about different changes that could happen. The first type of change is called a physical change, and this is where something happens to the material, but the composition of the material itself does not change. So it's a change during which some properties of a material change, but the composition of the material does not change. And what I mean by that is if you have water, H2O, there's several things you could do to that H2O to change it, but not change the fact that it's still H2O. For example, you could heat it up, you could put it in the freezer and turn it into an ice cube, you could pour it into a bunch of different small glasses, and all of those are changing the water, but it's not changing what water is. It's still going to be H2O. It's either changing the state of matter or changing the volume of the water. Those are all physical changes. So some examples would be like cutting. If you take a piece of paper and cut it in half, it's still paper. You haven't changed the fact that it's paper. You've just made it a different size or a different shape. Same thing with breaking and tearing. Grinding is taking something and just making it into smaller particles, but it's still going to be the same chemical composition. So if you take a sugar cube versus granulated sugar, they're both still sugar. They have the same chemical formula. It's just that one is a bigger piece than another. Phase changes is one that a lot of people tend to miss. So be careful with phase changes. If you go from a solid to a liquid or a liquid to a gas, you haven't changed what the chemical actually is. So whether you have water vapor, liquid water, or solid ice as water, it's still H2O. So watch for words that mean phase changes like melting, boiling, and freezing. And those are all going to be physical changes. Another one that tends to trip people up is dissolving. So put a star in your notes by dissolving and phase changes. Those are the two most commonly missed ones that I tend to see from students. Dissolving is when you just take a powdered form of something, put it into a liquid, and stir it up, and it looks like it disappears, which is why I think it probably confuses some people, but it doesn't actually disappear. It's still in there. So if you put sugar into your tea, you still have sugar in there, and you can taste it when you sip your tea. But it hasn't actually disappeared. And since the sugar and the tea are both still there, it's just a physical change. So be careful with dissolving and phase changes. With dissolving, you could actually get the substance back. If you, for instance, made salt water, you could get the salt back by evaporating the water off. So that means that it hasn't chemically changed. Chemical changes are the fun ones. These are the ones we're going to work on in class. This is when a substance is going to change its identity. So if it starts as water, H2O, and it ends as hydrogen gas and oxygen gas, that means a chemical change has occurred. Because you no longer have H2O, you now have hydrogen separate from oxygen. So this is when you do change the identity or the composition. Some examples for this are burning. So anytime you see fire, rusting, and decomposing. Some signs for that are things like color changes and smells. If you ever have a color change or a smell, it's usually an indication that a chemical change has occurred. And again, just to reiterate, these are the two that people tend to miss. Things that are not chemical changes would be phase changes and dissolving. So when you look at a list of changes and you're asked whether they're physical or chemical changes, there's some indicators that you can use to help guide you. And these are not perfect, but they tend to be a good guideline. Anytime you have heat, so if you mix two things and you fill the outside of a test tube and it feels hot, that means that a chemical change has occurred. Anytime you see light, so fire is definitely going to be a chemical change. And for gases, you won't actually see the gas. It's when you take two liquids at room temperature and you mix them together, you'll see bubbles that are given off. So if you see bubbles, that's going to be a gas. Changing color is a big one. So anytime in chemistry you mix two things and the color changes, that's an indication that probably a chemical change has occurred. Same thing with smelling something. So if you bake brownies, you have chemically changed the brownies. You can no longer get the brownie batter back after you bake the brownies. Number 3 is an important one, so put a star by that. Precipitate is the first vocab word for this chapter. There's not a lot of vocabulary for this chapter, but precipitate is one of them. It's a different word from the word you're probably familiar with. You're familiar with the verb to precipitate, which is from earth science, which means to rain or sleet or snow. This is a completely different word, but the problem is it's spelled the same. So you say it a little bit differently. You say it precipitate, and it means that a solid product is formed from two liquids. So if you take two liquids, pour them together, and you get a solid, that solid is called your precipitate. Keep in mind that you won't actually see like a rock. It's not going to turn into an actual solid. It's a solid that's floating in your solution, which means it's going to look cloudy. So the cloudiness is the solid that's floating around in your solution. So what I want you to do is circle the three words precipitate, solid, and cloudy. Those three words need to go together in your head. You need to know that precipitate is a solid, and that the way you know it's there is that it'll look cloudy. Excuse me. The next one is sound. So we've done this one in class before, that pop test that we did a while ago with the test tube where you stuck the match underneath it and you heard a pop. That was proof of a chemical change there. And the last one again is bubbles, is the gas given off, but be careful with that. If you're heating something and it bubbles, that means it's just boiling. If you see bubbles and you have not heated it, that's when it's a chemical change. And to practice this, if you look at worksheet 1 in your worksheet packet, there's a list of changes. You can use this guidelines to help you figure out if it's a physical or chemical change. There are two things I wanted to mention when signs of a chemical change are deceiving. So remember, those are just guidelines. Keep in mind that boiling, when you go from liquid to gas, is not a reaction, but you will still see bubbles. So if you heat something and you see the bubbles coming off of it, that's going to be boiling. If you take two test tubes that are at room temperature and you put them together and they bubble, that's going to be a chemical change. For example, if you take baking soda and vinegar, that's the classic volcano experiment that you see for like science fairs. Those two, when you mix them together, they produce a whole lot of bubbles, and that means that a chemical change has occurred. Another one to watch out is for color change. So if you look at the picture over here on the right, this person started with two clear liquids that look like water. They're not actually water, but they started with liquids that were clear, and they poured them together, and this is the result. They got something that was yellow, so they got a color change, and they got it cloudy. So you see how you can't see through the yellow? That means it's a precipitate. So this is a sign of a chemical change. If you dilute something, that means you're just adding water to it, which is not actually chemically changing it. But it will look like the color changes. So notice that over here it's light pink and over here it's almost a dark red. So it looks like the color changes, but you're just adding water. So be careful with color change and make sure you think about if it's an actual chemical change or not. Alright, let's talk about reactions. So again, this is when you form a new substance, a chemical change where you get something completely new. So the identity of the substance is different. What we're going to do is use symbols to show the chemical reaction. And now that you know how to write formulas and names, you should be able to write these equations by crossing your charges and writing all the symbols that we've been working on for the past week or two. There's a few terms that you do need to know. Before you mix two things together, we call them the reactants. So these are the starting things before you actually mix them together. So in your equation, it's going to be everything that's on the left of the arrow. This one is going to be A plus B yields C plus D. A and B are called your reactants. Once you mix them together, they turn into products because you produce something. So the substances produced in the reaction are called your products. And notice that for this one, it's everything on the right of the arrow. So your C and your D are the products. Everything on the left are reactants, that's what you start with. Everything on the right are your products. And that's what you end up with. And just a few more terms that you probably have heard in math before, and actually you've heard it from me too. When I say coefficient, I'm talking about the big number in front of a substance. So in this example, the 3 in front of the H2O is your coefficient. It tells the moles, molecules, or units, but don't worry too much about what it tells you for now. We're going to use that in our next chapter. For now, you just need to know if I say your coefficients are not balanced, you need to know where to look for your coefficient. And the next one is subscript. We've talked about that too. Sub means under and script means to write, so it's the writing underneath. So in this example, it would be that little 2 that's right next to the H. And this tells you how many atoms or moles you have of just that one element. So the 3 goes to the whole compound. The 3 is for the whole water. It means you have 3 H2Os. The little 2 only goes to the hydrogen. So it has nothing to do with the oxygen, it's just to the hydrogen. And the last thing for today are a list of symbols that you need to be familiar with. The arrow does not mean equals. Equals implies it's the same on both sides, and if it's a chemical reaction, they're not going to be the same items on both sides. So we use the word yields, or sometimes you'll see produces or results in. If you have both a forward and a backward arrow, it just means it's a reversible reaction. And we're going to do a whole section on equilibrium once we get to thermodynamics. So hang on to that word equilibrium, and we're going to come back to that later on. If you see something in parentheses after a compound, it's going to tell you the state of matter. So if you see parentheses S, it's just telling you that it's in the solid state. L is liquid and G is gas. The next vocab word for this chapter, like I said, there's not a lot. Precipitate is one. Another one is aqueous. So highlight the word aqueous, put a circle around it, underline it. This means that it's dissolved in water. And that's different from liquid. So a lot of people confuse those two. Liquid would be like if you took a pile of salt and you put it in a pan and you heated up the pan and the salt crystals melted into liquid salt. That would be liquid. If you took that pile and dumped it into water and stirred it up, you would be making an aqueous solution. And most chemistry is done as aqueous solutions because liquids flow over each other a whole lot easier than solids, but melting things all the time is time consuming. So scientists are going to tend to just dump it into water and stir it up, and that way they'll mix together well. And in fact, most of you for your honors project, the first step in your reaction will be to make your reactants aqueous. So you'll put them into water and you'll stir them up. And the last one is if you see a triangle on top of the arrow, it just means that you have to use heat to get the reaction started. So don't get too confused by that. It just means that heat is involved. And that is all for today.